In this video, I'm going to show you how to install a bad leveling sensor on your Anet A8 3D printer. Come and join me. Hi, my name is Daniel. Welcome to the Crosslink channel. On this channel, I'm doing regular reviews of 3D printers, extensions and modifications, and other gadgets. And if you're not subscribed yet, please consider subscribing to my channel and also hit the bell if you want to get notified every time I post a new video. This video is going to be about how to install a bad level sensor on your Anet A8 3D printer. So what's a bad level sensor? A bad level sensor helps your printer to find out how far the nozzle is away from the print bed. And that's specifically very important for the first print layer, because if you want the first print layer to stick very well to the print bed, the distance between the nozzle and the print bed needs to be very, very thin. And to do this without a bad level sensor, you have to use these 4 screws at the corners of the print bed to adjust the height and the leveling of the print bed versus the nozzle manually. And the problem with that is this doesn't work pretty well, and it always has to be redone every time you change something on your printer. For example, if you go and change the filament, this could also mean that you have to do the leveling again. And what the bad level sensor basically does for you is to do this whole process automatically every time a new print starts, and so you will never have to do any kind of leveling again once you have installed and calibrated this sensor properly. So let's start and walk through the steps needed to install this sensor on your Anet printer. So let's do step number 1, getting the right sensor for you. The point is, there is several sensors available on the market for the Anet printer. If you look on the 3D Print Wiki page, there is a list of available sensors that might work. I've put a link in the description below. I went for the capacitive sensor because that one works with every surface. So if you want to do printing on a glass bed, for example, definitely go for the capacitive sensor. However, it has a little bit of a drawback, which you can work around. It is a little bit sensitive to the room temperature and humidity, so you better make sure you have the same room situation, temperature situation when you do the initial calibration than when you do the printing. Otherwise, you might get different results. But for me, that worked pretty well so far, and that I had always very good results with this kind of sensor. So where do we get the sensor? We can go to eBay. Basically, you can buy this very cheap from China. The problem is it might deliver in 30 days. So if you want to do this right away and you want to start printing today or tomorrow, you can also go to Amazon and get it much faster for at least double the price. And these sensors, however, have all the same problem. They don't have the JST connector attached, which is needed for the Anet board. So you need to get one. You cannot reuse the one that's coming with the printer because that only has 2 connectors and you need 3 connectors. And there is another choice that I took to get a complete package, a sensor specifically already set up for the Anet board for about 17 euros. So I chose that one and it worked pretty well. So I can definitely recommend getting this one, and I've put the link in the description below. So let's do step number 2 now. Let's find a sensor holder for your capacitive sensor or the sensor of your choice. Where to go is you go to thingiverse.com and find a holder for your sensor. There is several sensors available. Some of them do mount the sensor to the back of your extruder, and some of them mount to the front of your extruder, like this one. It's basically up to you which one you choose. It also might be dependent on the situation, whether you want to attach other modifications to your extruder head, and that's also the reason why I went for the front mounting holder, because I had something mounted to the back of the extruder that prevented me from using one mounted to the back. And so basically you need to find out which one you need. I have put some links in the description below to several different holders for these kind of sensors. That's basically the part where you have to find out what fits best for you. So once you've chosen the right sensor holder for your printer, you print it out. And that's very important. You need to do this before you do any other modification to the printer, especially before you remove this end stop switch, because once you start the real modifications, the physical modifications, your printer is basically unusable until the very end of this video, where you do the firmware setup and the calibration, and then that's the point where you can start printing again. So you finally made your choice, you mounted your sensor to your printer, you also have chosen how to do the wiring, in my case the cable chain, and plugged in the cable. Don't forget to unmount the old Z-axis sensor, because that's going to block otherwise. And now let's measure out the X and Y distance of the sensor tip to the nozzle tip using this tool, and find out how many millimeters this are, because you need to write down these values and then put them into the configuration file of your firmware. Unfortunately, this cannot be done in the printer setup here, so we have to flash this into the firmware. So now I'm trying to measure out the distance in the x-axis, so I'm aligning the printer's nozzle with the middle of this ruler, and then trying to read the value. Yeah, the x distance seems to be 65, and this distance here seems to be 60 roundabout. So 65 and 60. So we did our measurements, and now we found that the X distance nozzle to sensor is 65 millimeter and the Y distance is 60 millimeters. However, these values we cannot use directly in a configuration file. We need to find out whether they are a positive or a negative value related to the nozzle. And to make this clear, I'm drawing the bed for you, so the printer seen from the front. Here we have in the lower left corner, we have the 0, 0 origin, and here we have the x-axis and here the y-axis, and our nozzle was around about here, and we did our measurement distance to the sensor right like this, and we measured that this distance is 65 and this distance here is 60. So what we need to put in the configuration file is whether these are from the nozzle a positive or a negative distance. So the X distance is a positive one because it's larger and to the right of the nozzle. So for the config file, we'll take the X distance as 65. However, the Y distance, in my case, in this printer, the nozzle is behind the sensor, and so we have to distract the 60 millimeters from the nozzle's position. So we actually put minus 60 in the configuration for the Y configuration setting. So let's take these values now and put them in the configuration file, and then let's do the rest of the configuration and flash the firmware to the printer. If you are not aware how to flash firmware to your Anet printer, please go and watch my other video about how to install the Marlin firmware on your Anet printer, and then come back to this video to see what values you actually need to change in that configuration file. Okay, now let's head over to the computer and put our values into the configuration file of the Marlin firmware. I recommend having a look at the 3D Print Wiki again, because there is a lot of explanation of which settings you need to do. The most important ones and resulting from our measurements are the X probe offset from extruder and the Y probe offset from extruder. Looking at my specific configuration file here, you can see that I've put in the values already, 65 and minus 60. And there is several other settings that you need to probably change a little bit for your printer. I have done a complete configuration change for the Anet A8. So if you want to take my configuration file and just change these two values, you should be fine. I've linked the file in the description below, and I've also listed all the changes that I made for the configuration. If you look at the 3D Print Wiki, you will probably see that this is a bit outdated because the settings have slightly changed for the latest firmware. You cannot really one-on-one adapt this. If you look at the settings, they can be found, but for example, enabling the bed leveling functionality has changed a little bit, and that's reflected in my new configuration file that you can download. So after making the changes, go ahead and flash the firmware to your printer, and then we are off for the final step, calibrating your nozzle and your sensor for your first print. So now, since you flashed your firmware, you're ready to do the calibration. Before we start, however, one thing that you really need to consider, you have to warm up the printer, so basically preheat the bed and also the nozzle, which is quite important because when these things get warm, everything might change a little bit in terms of deformation, and that makes your calibration much better. So go ahead and preheat your printer, wait for 10 minutes or so, really let it last a little bit, and then start the calibration. So how do we do that? We go to the printer menu and say prepare, and then go to the preheat PLA menu and say preheat PLA, which heats up the printer and your bed. So printer nozzle and bed, and now we are waiting for 10 minutes and then we can start the calibration. Okay, so now calibrating your sensor, quite easy. We go into our printer menu and look at the control menu and then the motion menu, and here we have the probe Z offset. That has to be set to something negative because the probe is actually higher than the nozzle. So we're going to start with minus 1.0 millimeters. And that means we have 1 millimeter to go down actually to play with the distance. So let's start with -1 and go back by one step and then save it by using the store settings menu item. It doesn't give you any feedback. It just makes sure that this value gets stored in the EEPROM, and when you turn off the printer and turn it on, it will remember this value so you don't lose it. So let's go back and first do in the prepare menu an auto home because the sensor needs to calibrate. And don't forget, always keep your bed heated, always keep the nozzle heated during this process, otherwise you will get different results. Okay, so now it's homed. We're putting in a piece of paper to see the distance, to feel it. And let's go in the menu now, and we go to the prepare menu this time, go to the move axis, go to move that, and then we're going to move the nozzle by 0.1 millimeters down. So to do that, push the lower button, and at the same time, every time you push this button, it decreases the height by 0.1 millimeters. You can hear it, and you can also, every time you decrease, you should move the paper a little bit and to see whether it's touching the paper yet or not. Let's see. And now I can already feel something. It's not much yet, but it's already there. So, okay, so here we have it. So we have sort of a little bit of resistance, but it's still not much. So I'm going to go down by one step. Okay. And now I can feel the motor vibration and the paper is still moving. So my experience is that when you can move the paper from the side without pulling,
when you want to go in this direction, it's absolutely the right distance. So there is resistance here. It's rubbing. You can feel the motor vibration a little bit. When you pull the paper, you can feel it in your fingers. That's the right distance. And now what we have is a distance of 0.4. That means we are basically, with our original offset, we are 0.4 millimeters too low. That means we need to increase the value by 0.4 to minus 0.6 in the end to have the right distance. I'm going to do that right now. So go back to the control menu and the motion and the probe offset, and then we are going to increase by 0.4 to minus 0.6. Go back one step, store the setting, go back, and then go to the prepare menu and do an auto home. Pull out the paper. Don't forget to pull out the paper. So printer is auto homing now, and we're going through the steps again. Once it's finished, so put in the paper. So you might be wondering, why is the paper now moving so easily? That's just because auto home gives you a little bit more distance. It doesn't go as low as it would when it starts printing. So let's go back to the prepare menu. Go move axis, move Z axis. Oh, that was the extruder. Z axis, and then move 0.1 millimeters. So now we have 0.6 millimeters to go down until we reach 0. And what we want to achieve is that at 0.0 we have the right kind of rubbing, so we have the right kind of resistance of the paper against the nozzle in the bed. So let's go down to 0 and see how this feels. And it feels absolutely right. It has this kind of resistance that I want. I can still move it. I can feel the motor vibrations, but it's not stuck, and I can still push it without having to pull in the other direction. So that's absolutely the perfect position.
Okay, so last but not least, final words about how to do your first print. I'm using Cura to set up my prints, to basically load the models and then slice them and send them to the printer. One thing that you need to do is on any kind of slicing software that you have, you need to set up your printer's initial G-codes to be using the auto level feature. And in Cura, there is, for each machine that you have, there is a settings page having all the settings, and there is also the start G codes, which are used to set up the print. And then after running through these G codes, your printer will basically start printing. Here you can see that there is a new G code introduced for auto leveling, and you have to use that after moving your nozzle to the end stops. And you can just copy this whole section and paste it to your preferred slicing software as your initial G codes. That works for me pretty well, and I'm putting this in the description of the video below, so you can just copy paste it to your software. And now let's print something. So what you can see is that the printer now goes through what I call the calibration dance. So it has 9 points where it measures the distance to the heat bed and then calculates the average for each point. And so it has a pretty good image of whether the plate is flat or if it's some bumps or curves. And then after the calibration, it will start printing our test grid. And that concludes this week's video about how to modify your Anet printer to have a bed leveling sensor. I hope you liked the video, so hit the like button. Also consider subscribing to my channel and use the bell to get notified every time I post a new video. Also, please use the comment section below to ask any questions and to post any considerations that you have, any ideas for new videos that I might want to do for you. So, if you want, we'll see each other next week on this channel for a new video about 3D printing, gadgets and more. Bye bye.